Hello everyone, picking up with week 9 notes on page 89 in your workbooks. We're going to start by building off of what we did in the last week notes. So for week 8 notes, we went over all the different methods of factoring. So we went over first GCF. GCF stands for greatest common factor, which is the type of factoring you always want to check for first, and it applies whenever there is a GCF to be taken out of all terms in your expression. If it doesn't have a GCF, you move on to a different type of factoring, which could be either of these next 4 bullet points on your notes. So if it doesn't have a GCF, what you're going to do next is count your terms. The amount of terms that I have will generally tell you what type of factoring to do. So for example, the next type of factoring on this list is DOPS, which stands for difference of perfect squares. You can only do DOPS when you have 2 terms. So if there is no GCF and it has 2 terms, chances are it's going to be DOPS. And I say chances are because it might not be the correct setup. You also have to make sure it is this setup, difference of perfect squares. Remember, a difference means subtraction. And perfect squares is the answer you get when you multiply something by itself. So for example, 9 is a perfect square because 3 times 3 is 9. Okay, if it has 3 terms, it's either going to be trinomial easy or trinomial AC. Remember, trinomial AC is like the OG. It's where it's at. It can be done to any trinomial. Trinomial easy is the shortcut. It can only be done when A is equal to 1. AC can be done when A is equal to 1, but it has to be used when A is not 1. If it's a 2, a 6, a 12, whatever it may be, if A is not 1, you have to do AC, but AC works all the time. Now when I say A, I'm just going to throw this up at the top of the page as a little reminder. A is that number in front of x squared in this standard quadratic format, ax squared plus bx plus c. Okay, then the last one we didn't talk about yet today is grouping, which is very easy to tell when it applies. You just do it when there are 4 terms. Nothing else to it. They don't have to have a certain number or, a subtraction, addition. It doesn't matter. If there are 4 terms, you do grouping. All right, so like I said, we're going to be building off of what we did in the week 8 notes, and it's going to start with factoring like we were before, but we're going to be doing factoring completely now. So what that means is you're going to have to factor using any of the methods until you can no longer factor. So you might have to factor twice or 3 times or even 4 times in one specific problem. I'll give you a big hint for this class. You are not going to have to factor more than twice in the same problem. So whenever you see something that says factor completely, it is going to be at most 2 times for this class. Okay, it is doable to factor more than twice. In a future math class, you may have to do something like that. On a bonus for this class, you might see something a little bit like that. But for tests and quizzes, questions that are mandatory for you to do, you're not going to have to factor more than twice. So here's what I mean by that example, speak it volumes. So question 307 is 2x squared plus 4x minus 16. I counted right away and I had 3 terms, but I don't want to get carried away because I remember I have to check for a GCF first always. So when I look at a GCF here, it actually does have one. So I have to do the GCF type of factoring first. Between 2x squared, 4x, and 16, they all have a 2 in common. Not the x because the 16 doesn't have it. So if I recall my GCF method of factoring, I need to take all 3 of these terms and divide them by 2. Once I divide by 2, my setup for GCF is to put that GCF of 2 out in front with a parentheses after it and then divide. 2 divided by 2 cancels and I'm left with an x squared. 4 divided by 2 is a plus 2 and the x comes down. And negative 16 divided by 2 is a minus 8. Now, last week you would have been done at this point, but we are factoring completely, which means you keep factoring until you can't anymore. Or specifically, we're going to factor twice. So I look at what's remaining, and now I need to factor that piece. So I'm going to ignore the 2 on the outside for now and just look at what's in the parentheses here. Since I've already done GCF, I now need to count my terms. So I have 3 terms in the parentheses there, and I notice that A is a 1. So this is going to be trinomial easy. Okay, you can do AC, but remember, it's just a few steps longer. So I'm going to do the shortcut. If you want to do AC, you will absolutely get the right answer still. All right, so a refresher on how to factor a trinomial. You take that number that's by itself, which is a -8, off to the side, and you list the factors of just a regular 8. We'll deal with the negative later. So 1 times 8 and 2 times 4. From that list of numbers that multiply to 8, you need to also pick the pair that adds to the middle number. Remember, it's like a puzzle here. It has to multiply to this number, add to the middle number. Now, remember, we're multiplying to a -8. Here's where my negatives are going to come into play. To multiply to a -8, I need a positive number and a negative number. Since I'm adding to a +2, try and take a second to pick the pair that's going to work both ways. Again, to multiply to -8 and add to +2. Hopefully, we got a -2 and a +4. -2 times +4 is -8, and -2 plus +4 adds to 2. So they both check out. I'm ready to write out my answer because remember, I can use the shortcut. Easy method applies here. So I'm going to write my factors as x minus 2 because it's negative and x plus 4. And the only really new part here, other than factoring twice, is you have to remember to bring down what you ignored for that type of factoring. The 2 is part of your answer. And I am done. Now remember, every type of factoring can be checked. That still applies. Your check is just going to be a little bit longer. So what you would have to do, and I'll just show you real quick for this one. Just rewrite it real quick. X plus 4. All right, you have to distribute everything through. Now be very careful when you do this because you start by distributing this 2 through, but it only gets distributed until the parentheses end. So it only gets distributed to the x, so I get 2x. And then to the -2. So 2 times -2 is a -4. Now, that whole thing is a group. I'm going to put it in parentheses as a binomial, and I'm going to bring down this x plus 4. And hopefully you notice at this point, this is what you're used to checking. So it's really not much different. You just have to distribute the GCF through first, and you don't distribute it through to both of them because it's almost like at this point I'm going to distribute it through to that other group now. So 2x times x is a 2x squared. 2x times a +4 is a plus 8x. Then I distribute this -4 through. -4 times x is a -4x. And -4 times +4 is a -16. And remember that last step just to make sure it checks. Combine these like terms. So you get 2x squared. Sorry, I'm just running out of space. 8 minus 4 is going to be a plus 4x. And then the -16 comes down and you get exactly what you started with up here. Okay, so that's the only check I'm going to show you for factoring completely because, again, it is the same idea. You just check every type of factoring by distributing. If you want to go through and distribute to make sure you get it right on a test or a quiz, by all means, okay? Now let's try another one, 308. First type of factoring I always look for is GCF, and this one also has one. So I'm going to start by doing the GCF method of factoring. Okay, between 10, 35, and 30, the biggest number that goes into all of them is 5, and they all have a y in common. So my total GCF is going to be 5y. So I start by doing exactly what I did in the last problem and dividing by that GCF of 5y, and then my setup is the 5y comes down followed by parentheses. And then I divide. So 10 divided by 5 is 2. Remember, when you're dividing variables, think about it like this. Y to the third is y, y, y. There's 3 of them. Divided by y to the first is just 1y. If you divide these, you'll have 1 on top and 1 on the bottom cancel, and you'll be left with 2 y's, so that's going to be a y squared. All right, next, -35 divided by 5 is a -7, and then y squared divided by y, same idea. If I have 2 on top and 1 on the bottom, 1 will cancel again on the top and bottom, but it'll only leave me with 1 on top. So -7y. And then this last one, both of those y's cancel, and 30 divided by 5 gets me a plus 6. Now I'm factoring completely, so now I need to look at what is remaining in the parentheses here and try to factor that. So you do so by counting your terms. There are 3 terms here, so it is a trinomial. Whoops, trinomial. A trino. What am I doing? Here we go. A trinomial. AC, specifically AC for this one because I have a number that's not 1 in front of my y squared, so I must do AC. I can't use the shortcut, unfortunately. So AC tells you what to do. It's right in the name as your first step. A times C, if I go back up to this, remember A is the first number, C is the last number, so A times C is what I'm going to start with. In this case, it's going to be 2 times 6, which is 12, a positive 12. So off to the side, I list the factors of 12. I have 1 times 12, 2 times 6, and 3 times 4. Now I'm multiplying to a positive 12, which means either a positive times a positive or a negative times a negative. And in this case, I'm adding to a negative 7, so I definitely want negative, negative. So take a second to try and pick which pair you want. Hopefully we get negative 3, negative 4. Again, you can't use the shortcut for this one. So my advice to you, because we're about to get into this AC method, if you remember, and hopefully you do, that's going to turn into grouping. Once we have 4 terms, you've got to take out GCFs with grouping. It's a lot of extra steps, and this right here, this 5y, is going to get sloppy if I leave it out in front. So I'm just going to draw an arrow to remind me to bring it down at the end after I do all these steps. And I'm just going to factor this on its own. So because it's AC, I do my AC setup. My 2y squared comes down. I split the minus 7y into the 2 numbers that I picked. So minus 3y, minus 4y. Remember, the order of those does not matter. And then the plus 6 comes down. Okay, now that I have 4 terms, I can do grouping. So I group my first 2 terms together, group my second 2 terms together. Make sure you get that negative with the 4 inside of your second group. And then GCF each. So the GCF of my first group between 2y squared and 3y is just a y. So I put that y out in front. Okay. 2y squared divided by y is going to be a 2y. A negative 3y divided by y, the y's cancel and just leave me with a minus 3. Okay, now remember the goal here. You want this to match up with whatever you get when we take the GCF out of this second group. Right now I have a negative 4y. I need it to become a positive 2y. That tells me my GCF has to be negative. If you don't see it right away, that's okay. Give it a try with a positive 2 as your GCF. But ultimately, you need to get that negative out in front of the 2. Okay, so now I divide negative 4y divided by negative 2 is a positive 2y, so I'm starting to match already. And then positive 6 divided by negative 2 is a negative 3, and they match entirely. So remember what you do when they match. When they match up, you bring down that binomial 2y minus 3, but you only bring it down once, and it's gone from that last step. Now your next group is going to be your 2 GCFs put together, y minus 2. And you are done, but you are then going to see this arrow you drew for yourself, and you're going to remember that that GCF you took out in the very first step is also part of your answer, and you're going to bring it down. And that's your final answer. All right, let's move on to the next one. 309 only has 2 terms. Remember, counting your terms doesn't necessarily matter right off the bat, though, because you have to check for a GCF first. So between 12x cubed and negative 3x, I want to see if it has a GCF. It does, so I'm going to start by doing my GCF method of factoring. Between those 2 terms, my GCF is 3x, so I start by dividing just the 2 terms that I have by 3x, and that 3x comes out in front. 12x cubed divided by 3x. First divide your numbers. 12 divided by 3 is 4. X cubed divided by x. Remember this picture that we had in the last one? Same idea, but with x's, it's going to get me an x squared. And then negative 3x divided by 3x. If you look at it this way, it's something divided by itself, which is just a 1. But if you look at it another way, you can cancel everything out. But if you think about it this way, where everything cancels, the 3's and the x is gone, you still need to bring something down, because if you remember, you check all factoring by distributing, and you have to be able to distribute that 3x to the negative 1 to get that 3x back. So it should check out when you distribute it back through, and it does if you put the 1 there. It will not if you forget the 1, so it's super important. Okay, I'm done with GCF. Now I need to look at what's remaining. I only have 2 terms. Remember what type of factoring goes along with 2 terms? DOPS. But you also have to make sure it's the right setup. Difference, which I have, subtraction right there, of perfect squares. 1 is a perfect square, 4 is a perfect square, and x squared is a perfect square. Remember, a variable is a perfect square if it has an even exponent. Sorry. Okay, so it is ready for DOPS. I'm going to apply the DOPS method. Now, hopefully we remember how to do DOPS. You start by taking the square root of each term. So I'm doing the square root of 4x squared and the square root of 1. Now the square root of 4x squared. First, the square root of 4 is 2, because 2 times 2 is 4. When you take the square root of x squared, you have to think what times itself will get you x squared. It's going to be an x, because x times x is x squared. And the square root of 1 is 1, because 1 times 1 is 1. All right, now your setup for your answer for DOPS is going to be the same every time. 2 sets of parentheses, 1 with a plus and 1 with a minus. Then you fill in the blanks with what you get after you square root everything. So 2x goes here, and then the 1 goes here and here. 2x plus 1, 2x minus 1, and then don't forget that GCF you had in your first step comes down in your answer. And we're done. So just an example of what you might want to look into in the future if you continue a math class like this, or you really want to get that bonus that you might see on a test or a quiz. Factoring completely is, like I said, factoring until you can't factor anymore. We did GCF, then we did DOPS. You want to see if you can factor again. You won't have to, like I said, on a test or a quiz question, but maybe on a bonus or a future math course, you will have to factor more than twice. So here's what you would want to look for. Okay, obviously the 3x is one term. It can't be factored again. Here I have 2 terms. The type of factoring that goes along with 2 terms is DOPS, but right off the bat I know this isn't DOPS because it's being added. So then I look at my last factor here, 2x minus 1 has 2 terms. It also has subtraction, but 2 is not a perfect square. So no other types of factoring apply, which tells me right off the bat I can't factor this anymore. Okay, so that's what you'd want to look for, like I said, for a bonus or a future math class. See if another type of factoring applies. For this course, you're only going to have to factor twice. All right, so let's try it again. For 310, factoring completely. 3x squared plus 9x plus 12. Oops. Does have a GCF, so I'm going to start by doing that GCF method, and the overall GCF between all 3 terms is 3. So I start by dividing all 3 of them by my GCF of 3, and that 3 comes out in front. When I divide 6x squared by 3, I get 2x squared. When I divide 9x by 3, I get plus 3x, and then 12 divided by 3 is a plus 4. So I've completed one type of factoring. I now need to check to see if I can factor what is left in the parentheses here. It has 1, 2, 3 terms, so it's a trinomial. And it's got a 2 in front of the x squared. So this is going to be trinomial AC. I cannot do the shortcut. So I start by doing a times c, which is 8, and I list my factors of 8 off to the side, which is just 1 times 8 and 2 times 4. Remember the goal, you're trying to pick the pair that also adds to the middle number. So take a second to try and figure out which pair multiplies to positive 8 and adds to 3. Hopefully you're seeing a problem. You can't pick a pair. There is no pair that exists. So what we're going to do is just bring that down as our final answer. So if you go back up to the top where we talked about factoring completely in the beginning, right here, I added this on because it's super important. Factoring completely means for this class, you can factor at most 2 times. It doesn't mean you have to. So this is factored completely. I have factored until I could not factor anymore. You might only have to factor once. You might have to factor twice. You can factor 3, 4, 5 times, whatever. Okay, but sometimes it's only going to be once, so keep that in mind. All right, we are going to do this next example, but I don't want you to stress about it. If you remember in the last week of notes for week 8 notes, when you had an exponent like this, I told you not to worry about it. You won't see it on a test or a quiz. That is still the case. It's just a really good example to go over. Okay, so for 311, it's x to the 4th minus 7x squared plus 12. This one does not have a GCF to be taken out. Yes, I know 1 can be taken out of everything, but that won't change it. You only want to take out a GCF of 1 when you are dealing with grouping. Okay? So then I go on to count my terms. This one has 3 terms, so it is a trinomial. And luckily, this one has a 1 in front of that first variable, so it is trinomial easy. So off to the side, I just need to state that number that's by itself, which is 12, and list the factors of it. So the factors of 12 are 1 times 12, 2 times 6, and 3 times 4. Now from that list, I need to pick the pair that also adds to the middle number. This one should look a little bit familiar. It's a lot like the question 308 next to it, where we had to find the factors of 12 that added to -7, but this one can be used with the shortcut. That one needed AC. But it's the same idea with picking the pairs. So my pairs are going to be, or my pair is going to be -3 and -4. Now using that shortcut, because this is the easy method, it's going to be x minus 3, x minus 4. Now when I go to check this real quick, x times x does not get me x to the 4th. That was the big issue we had when we tried to do this example in the week 8 notes. So the way that you fix that is you put a squared here and a squared here, so that now x squared times x squared does get you x to the 4th. When you multiply through to these next 2, the x to the, -4 and the -3 to the x squared, you're going to get this x squared in the middle, and so on. So it will check out when you distribute it through if you just add those squareds to it. Now I've only factored once. I need to see if I can factor again. So I look at my first factor here, x squared minus 3. It has 2 terms, and it does have subtraction, so 2 terms normally goes with the difference of perfect squares. I see the difference right off the bat, but 3 is not a perfect square, so DOPS does not apply to that. I can't factor what I've just underlined in purple. So I look at this next group, x squared minus 4. Same idea, it has 2 terms, so I need to consider DOPS, and it is subtraction, so I'm on the right path. X squared and 4 are perfect squares, so this one DOPS applies. So I am going to do DOPS to that one. So remember what DOPS is. You take the square root of each of your terms. We did it already once. So I need the square root of x squared and the square root of 4. So the square root of x squared is x, and the square root of 4 is 2. And then I need to recall my setup for DOPS is the same every time. 2 sets of parentheses, one with a plus and one with a minus. X goes in the first space, 2 goes in the second space. And then that x squared minus 3 comes down in front because it couldn't be factored. It's almost like a GCF where you would just keep bringing it down. If it couldn't continue being factored, it is still part of your answer. And that's it. All right, one more on this front page with factoring completely, then we're going to steer away from factoring completely for a minute. So again, first thing you want to see is if it has a GCF. This one does not have a GCF, so I move on to count my terms. There are 2. When I have 2 terms, I need to look at DOPS. Make sure the setup is correct. D stands for difference, which I have, and then the PS is for perfect squares. Again, I also have that. So I'm going to start by doing DOPS. So off to the side, the square root of x to the 4th. Think about it. What times itself will get you x to the 4th? We kind of just looked at it up here. When you check x squared times x squared, you get x to the 4th. So the square root of x to the 4th is going to be x squared because, again, x squared times itself get you x to the 4th. Square root of 16 is a little bit easier. That gets me 4. So when I go to set up my dots, 2 sets of parentheses, one with a plus, one with a minus, fill in the blanks with what you got. So x squared plus 4 and x squared minus 4. But we are factoring completely. I don't know that I'm done yet. I have to check each group to see if it can be factored again. So in my first group, I count. There are 2 terms again. I need to see if DOPS works. DOPS can be done more than once. Okay. So DOPS, again, stands for difference, and I notice right away there's a plus sign there, so DOPS does not apply to this. It's just going to come down in my answer. It does not factor again. All right, this next one, x squared minus 4, also has 2 terms, which normally goes with DOPS. I need to make sure it's the right DOPS setup. It does have a difference, and those are perfect squares, so I'm actually going to do DOPS again. So I need to take the square root of x squared and the square root of 4. X squared's square root is x, and the square root of 4 is 2. Notice the setup never changes. 2 sets of parentheses, one with a plus, one with a minus, and I get x plus 2, x minus 2. And that's all. Final answer. Now checking one like this where you end up with 3 binomials is a little bit harder. I'm not going to walk you through it completely, but I will show you what you would want to do. You pick any 2 to start with, and you double distribute it through. So this, I'd pick these last 2. I would distribute that x through, distribute the 2 through. This would come down, and then I'd be left with something here, and I would just distribute through to that, blah, 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 blah. Okay, if you want to see a check like that, I will absolutely set one up for you. I might have it on my key, though I don't think I do. But it's the same idea. You just keep distributing until you end up checking out what you got at the end. All right, so like I said, steering away from factoring completely just for a little bit, we're going to start working on solving quadratic equations. So remember what it means to be a quadratic. You've got that ax squared plus bx plus c. You might be wondering what what factoring has anything to do with this course. Like, what does it mean? Why are we doing it? What's its point? Here is its point. That might be answering your question right away. So before I read any of those words, I want to direct you to this first example. X squared minus 5x minus 24 equals 0. When we have solved every single equation in this course up to this point, there was just an x in it. If there's just an x, remember, you get everything away from the x by doing the opposite. If you have something added to the x, you subtract it from both sides, and so on until you get x by itself. If you try to do that for this example here, where you have an x squared and an x, it will never work. If you move this over here, or you move this over here and that over here, you're always going to have 2 different x terms, and you're never going to be able to get x by itself because, again, there's 2 different x terms. You can't even combine them because they're not like terms. This is why factoring comes into play. So before we dig deeper, and I'll show you exactly how this is solved, I really want you to star this, underline it, highlight it, whatever you want to do. Anytime you are solving a quadratic, which is in this setup, you have to be equal to 0. If you're equal to something that's not 0, you need to move it over before you start. We'll get into an example like that, I believe. Yeah, the next example will show you what that looks like. So I'll remind you of that for the next one. Okay. Once you're equal to 0, you can start factoring, which is what the next step says, and then we'll talk about this next step once we're there. So for 313, again, I have x squared minus 5x minus 24 equals 0. I need to solve this by factoring. So it's already equal to 0. I know I'm allowed to start factoring, but now I'm just going to look at this piece for the factoring aspect. So I look to see if it has a GCF. It does not have one, so I move on to count my terms. X squared minus 5x minus 24 is 3 terms, so this is going to be a trinomial. And there's a 1 in front of the x squared, so this is luckily a trinomial, easy. All right, so for trinomial easy, I need to take that number by itself, which is a negative 24, and list its factors off to the side. I'm running out of room on the right, so I'm going to do it off to the left for this one. Remember, don't worry about that negative for now. I'm just going to do the positive factors of 24. So I have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Now from that list, just like before, I now need to pick the pair that adds to negative 5, keeping in mind that I'm multiplying to a negative 24. So I need opposite signs, one positive and one negative. Take a second to try and pick your pair. Hopefully we got a positive 3 and a negative 8. So using the shortcut, actually, just so we get you in the habit of it, double check those numbers. Positive 3 times negative 8 is negative 24. That checks out. And positive 3 plus a negative 8 is negative 5. That checks out. Your whole answer depends on you picking that right pair. Just do a quick little check. Okay, so positive 3 and negative 8. Using my shortcut, I'm going to write out my factors as x plus 3, x minus 8. And I know I said to ignore that equals 0 then. I want you to bring it down now. Now if you notice, this can't be factored again. X plus 3 and x minus 8 do not apply to any of the other types of factoring. So here's where the solving part comes into play. This last bullet point up here on the how to do it. It says set all factors equal to 0 and solve each separately. Next to that, I want you to write T it up. Okay, T it up. So what I mean by that is you're going to draw a T in your problem. You have two factors here. One of them is x plus 3, one of them is x minus 8. You're going to draw a line through the center of them and then draw a line underneath them. Notice I just drew a T. That's what I mean by T it up. Once you're done factoring, you split up all of your factors with a T. You T it up. And then it says set your factors equal to 0. So underneath the left side of my T, I'm going to write x plus 3 and I'm going to set it equal to 0. Underneath the right side of my T, I'm going to take that x minus 8 and I'm going to set that equal to 0. And then I'm going to solve each side. So factoring, split it up so that you have two solvable equations and you're actually going to get two answers that work. So when I solve this first equation, x plus 3 equals 0, I'm trying to get x by itself. To undo plus 3, I subtract 3 from both sides. This positive 3 minus 3 cancels and x comes down. 0 minus 3 is negative 3. So one of my answers is x equals negative 3. Okay, next, x minus 8 equals 0. To get that minus 8 to the other side, I add 8 to both sides. So negative 8 plus 8 cancels, and I get x equals 0 plus 8, which is 8. Now you guys can 100% leave your answer like that. That is perfect. I see both answers. It's clear. If you look at my answer keys, you'll notice they're written in these little squiggly wiggly things. That's another way of writing out if you have more than one solution. You can even use it for one solution. It's called a solution set, where you could list all of your solutions. If you write it like this, that's fine. You will not lose credit if you don't write it like this, okay? This is perfectly correct. I just wanted you to know what those little squiggly things meant on my answer key. All right, now we're going to get into graphing this. So the graph of this is going to come straight from your equation. I want you to write this above the graph. Y equals x squared minus 5x minus 24. Notice the x squared minus 5x minus 24 just was carried over. You are just going to put it in the y equals in your calculator. So to graph this on the graphing calculator, what we're going to do is type it into the y equals the same way that we did from the week 7 notes. So remember that y equals button is on the top left of the calculator. You probably have an equation somewhere typed in there, so make sure you clear all of your y equals out. And we're going to type in this equation. So the first term is x squared. To type that in, I'm going to start by pressing x, which is that right there. And then the squared button is over here on the left. I know the button says x squared, but you have to hit that x button first. So there's x squared. Some of you might be using a calculator that has a small cursor above, up in the exponent next to the 2. If that is the case, you don't want to keep typing up the rest of this up in the exponent. So press that right arrow to get down and have a big cursor like I do. And then we continue typing this in. The next term is minus 5x, so minus 5x. And then the last term is minus 24. Now there are two things that you can do with the graphing calculator. The first one is you can press graph up on the top right of your calculator to see what your graph is going to look like. Now in the week 7 notes, when we pressed this graph button, we were trying to get our axes to go out to -10 and +10 on both the x and the y axis. If you look at your notes, that's not the case for this setup. This setup is a little bit different. You'll notice the x-axis goes to a minimum of -5 up to a largest value of 11, and the y-axis goes all the way down to -30 and only goes up to a +2. So I already have my graph set up like that, and I'm going to show you how to do that. So first of all, if you're using an app, you can zoom in the same way that you would zoom into a picture, like so. If you don't have that option, or if you'd prefer it be perfect and you don't really like the zoom option, you can press this window button next to your y equals, and you can type in the exact scale that you want. So like I said, the minimum value on the x-axis that's given to us is a -5. So I'm going to type in -5 for my x min. And then the biggest value on my x-axis is 11, so I'm going to clear out that value and type in 11. So now my graph will be set up perfectly on the x-axis. I need to do the same thing for y. So the y minimum, or the lowest y value on my y-axis, is a -30. And the biggest value on my y-axis is a +2. So really you're just kind of explaining to your calculator what the grid on your notes looks like. So that when you press that graph button to see what the graph is supposed to look like, it gives you an exact picture of what you're going to be seeing when you graph it on your notes. Okay, now pressing that graph button again, it just gives you an idea of what the parabola is going to look like. So you have an idea of what it looks like before you start plotting points, but ultimately you need to be plotting points. So to get those points, rather than just pressing graph, you're going to press second graph, and that's going to pull up your table. So if you notice, my table is way too small, I should say, but those numbers on the y-axis are way too big to be plotted. Remember, the biggest y value we have is a +2. So you need to figure out what direction to change your table to, like to go up or down. We definitely want to go down because those x values are way too small. I need to go to some bigger x values. And by bigger, I mean more positive. -74 or whatever we were at, it's never going to work. I need to get to a higher valued number than that. Oops. I don't even know what I just pressed. All right, so the smallest x value we have is -5. But -5 has a corresponding y value of +26, and we can't plot that. If you remember, when we were doing the week 7 notes and we were graphing our first parabolas in this course, our goal was to find the x values and the y values that stayed within that -10 to +10 range. In this case, it's a little bit harder, but it's the same kind of thing with figuring out what points are plotable. Because we can plot a -5 in our x-axis, but 26 is too big to fit on the y, that's not a plottable point. So you need to keep going to find the next plottable point. Next is -4, 12. Again, my biggest y value is 2. That's not going to work. So the first plottable point here is -3, 0, because -3 is an x value on my graph and 0 is a y value, an available y value on the graph. Okay, and as a reference point for you guys, that -3 is 0 as a point. It's kind of like when we were doing systems of equations. We wanted to see where they intersected. You always write your points as x, comma, y. So even though this is in a table, all of these points are in that x, comma, y format. So I'm going to plot each point like so. That first point is where x is -3 and y is 0. So I go to the left at -3, and I don't go up or down at all because that's where y is 0. My next point is -2 for x and -10 for y. So on my x-axis, remember this one's x and then y to the sky is the vertical one. My x-axis, I go to -2, so that's right here. And then I need to go down to -10 and put the point where both of those match up. -2 and 10, -10. Then -1, -18, so I go left to -1, down to -18. And I follow that same pattern all the way through. When x is 0, it means I'm right here. I don't go left or right at all. I don't put the point there though. I build down from that and I go down to -24 like it tells me to. And so keep plotting just like so. If you need more time to graph it, pause it just for a second and then pick it up right here where you when you finish up. But if you remember, something that we talked about before week 8 started was what a quadratic is. When you graph a quadratic, I told you guys it's going to be a parabola and it's going to look like a U-shaped graph. It's kind of hard to see it on here. You can definitely tell it's a curve. It's not a line anymore. But when you go to connect it, you want it to look like a U shape. So I go to connect this like so. When I get to the bottom, I need it to be a curve. Do not plateau it there. You need to curve it. Oh, that's not pretty. And then curve it back up. It's really hard to graph on this. Okay, so again, you just want it to be curved at the bottom here. Hopefully yours is prettier than mine. And then arrows at the top because, like we said, even though you can't see it on the grid, your graph does still continue in that upward direction. Okay, so again, pause the video if you're not ready to move on. This next part is hugely important, so I definitely need your full attention and I need you to be done with what you're doing on your paper before you draw yourself back to this. Okay, notice your answers, which sounds kind of weird, but your answers were -3, 8 when we solved this algebraically. Look over at your graph and try and find the significance of -3 and 8. Hopefully you see -3 and 8 are where the graph crosses the x-axis, and I want you to write that down. Your solutions are where the graph crosses the x-axis. Solutions are where the graph crosses the x-axis. That's definitely something you're going to want to know for upcoming tests and quizzes. Just a little add-on for why that is. You'll notice where we put this y equals was in place of the 0. So what we're saying when we did this right here is that y is 0, and y is always 0 on the x-axis. So it'll always place your solutions on the x-axis like that. All right, super good point to end at. Make sure you know that when we start the next video, because we're going to do another example. And I'm going to end you right there for today, which means I need to give you your code word right at the very end. So code word for this is going to be cheese. Okay, so write down that code word for this first video for the week 9 notes. Your code word is cheese. All right, and I will pick up with you guys for the second half of the video.